Alright, new series explaining Unity programming functionality, and to start us off, we're going to be looking at one of my personal favourites, Lerp. So what is Lerp? Lerp is short for linear interpolation. It's a way of smoothly blending between two values over a given factor called t. It's really quite simple. You give it a start value, an end value, and a t value between 0 and 1. When t equals 0, you get the start value. When t equals 1, you get the end value, and anything in between is a mix of the two. For example, if we want to lerp from 0 to 10 with t equals 0.2, the result is 2. If t equals 0.6, the result is 6. So to show you an example of this, I've set up a scene which has 3 cubes. Red cube is the start point, blue cube is the end point, and green cube is our example cube, which will be moving. I've created a new script and I've attached it to the green cube, called it something like Lerp Mover, and inside of our script we have some variables. We'll have our start point, end point, a speed, and an offset for the y, just so that the cubes don't overlap. Essentially what's happening inside of this script is we're moving our green cube back and forth between the red and the blue cube. And this example, I think, shows our lerp very well. We're creating a new float called t, and this float is going to oscillate between 0 and 1 over my speed using Mathf.pingpong, which we'll cover more in detail in the future. Then we're creating a new vector 3 called target position and lerping it from our start point's position to our end point's position, and basing this on the t float, which goes back and forth between 0 and 1. Below, I'm just applying an offset so that the cubes don't overlap and setting the cube's transform position to the target position we've just made. Through this, you can see how the t functionality works pretty well through that oscillation. So I've quickly just added a print into there so we can see the t value as it increases and decreases, but if I press play now, you'll see that the green cube will move back and forth between the red and the blue cube, and in the console, you'll see that our t value is oscillating between 0 and 1. Now, yeah, this is useful, but it's not the most useful application. So one of the most useful applications that you can find this for will be something like health bars, stamina bars, like super useful for this. For something like this, however, we're not going to use the normal lerp. There's a starman waiting in the sky. We're actually going to use a little something called InverseLerp.
Oh, DD, oh, what it is? Oh, DD, what it is?
Which is also really useful, and I use it all the time. InverseLerp essentially just determines where a value lies between 2 points and gives you back a 0 to 1 value based on where it lies. So in our case, say we're focusing on something like stamina. We have a minimum stamina, which will be 0, and a maximum stamina, which will be 100. Say we have been sprinting for a little bit and our stamina has reached 50. If we do an inverse lerp, our output will be 0.5. So you can see how this is the inverse of what lerp does normally. Now this is really important for if you want to use it for something in like a slider, because a slider only takes a value between 0 and 1, whereas if you're using stamina, you most likely want to have it be above 1. So in my scene, I've pretty much just created a normal slider. I've named it stamina slider just for this example, put a bit of a text above it just as a visual. And inside of my script, I've got a reference to the stamina slider, a max stamina, a stamina drain speed, and a stamina regen speed. And I've also got a private float for our current stamina. On start, I'm setting our current stamina to our max stamina, just to be safe. Then inside of my update, I'm checking to see if they're holding left shift. If they are, then I will subtract my current stamina by our stamina drain speed multiplied by time.delta time so that this is a consistent rate. Else, if they're not holding left shift, then we'll add our stamina regen speed multiplied by time.delta time, and this will increase our current stamina. Below this, I'm just clamping using Mathf.Clamp our current stamina between 0 and our max stamina, just so it doesn't go out of these bounds. Now for the important bit, this is where we're going to do our inverse lerp. I'm going to create a new float, call it t. And we're going to do Mathf.InverseLerp 0 for our minimum, max stamina for our maximum, and our value float is going to be current stamina. If you hover over InverseLerp, you'll see it will tell you determines a value where it lies between 2 points, and maybe float A, float B value. So this is essentially figuring out where our stamina falls between 0 and 100. Now below this, your stamina slider dot value is going to equal t. Now if we go into play mode, you'll see that when you press left shift, the stamina slider will slowly and smoothly head down towards its minimum value, and when you let go, it will slowly and smoothly go back up to its maximum value. So for an actual game, there's obviously stuff you would want to change with this, like a regen cooldown time so that you don't just immediately start getting your stamina back, but this is just a basic example to show you the use case for inverse lerp. But wait, there's more! So obviously in the first example, I didn't do Mathf.Lerp, I just did vector 3 lerp. Now the Mathf.Lerp works essentially the exact same. It's just easier to pass vectors into there, but you basically would just use normal floats and stuff in your Mathf.Lerp. But yeah, anyway, I'm going to end it here now, so I hope you enjoyed this video and you found it informative at least, and you can use some of these examples that I've showed you. And yeah, I'll see you later.